This is activity 9-1 transformations. And I got to tell y'all, I am nervous about teaching transformations without patty paper. Um, I may try to figure out a way to show you. You may not have any patty paper yourself, but maybe your parents, your mom, your dad, or grandmother, or whoever you live with, may have some wax paper um, in the kitchen, and wax paper will work pretty much as well as patty paper does. I don't even think I have any patty paper here at my house. But anyway, we're going to try to make do without. The only reason why I like it is for rotations. I don't have very good visual or imagination that allows me to visualize some of these changes that we're going to be making without actually physically seeing it. And the patty paper helps me do that. But anyway, if you just know that if you are a hands on type person, you may want to ask whoever you live with if you guys have any wax paper in the house. If you don't have any wax paper, a piece of notebook paper will work if you have um, something that is very boldly printed. You can work with it. Anyway, enough about that. Let's go on here. So, um, transformations in general are a transformation is just a change. We're changing it somehow. And depending on what kind of change we make, will determine which one of these words we use to describe our transformation. So in this first section, um, they give us an example right here. And I think that this is a little misleading because really what's happening, this is not a different piece of paper. What's really happening right here is that they're taking this image right here. This is the pre-image. I'm sorry. If you pay attention to the vocabulary over here, the original figure is called the pre-image. The transformations compare the pre-image. That may be something. Oh, it tells you right here. The pre-image is the original, and then the image is after the transformation. So this one right here is our pre-image. And that's probably going to be right in the way of something that I need in a minute, but that's okay. This is the pre-image, and what they're really doing is taking this pre-image and they're sliding it down until it gets to right about here. And then then they're asking you to compare it. So to move it over here, I mean, I guess you just need to imagine that that pre-image is still there. It's really what you need to do. Okay. So anyway, what happened is that we just did what? We slid this down. So anytime we slide it down, a couple of things happen. One, we say it maintains its orientation. In other words, you should recognize that this is a rectangle. I believe rectangle is an image, a geometric shape that you've learned in previous courses. So I think it's okay for me to say that this rectangle is oriented right now so that it's a tall rectangle rather than a wide rectangle. It's standing tall rather than laying wide. Okay. So it maintained that image. It's still a tall rectangle when we slide it down. So it maintains its orientation and it's also maintained its size. So it kept its size. Okay. And one thing that we could do to prove that it maintained its size is we could find the area of this one. We could say that this one is 1, 2, 3, 4, 5, 6, 7, 8 units tall and 1, 2, 3, 4, 5 units wide. So I believe you guys remember from earlier courses that that would mean that that is 40 square units. Okay, well, you come down here and you measure this one or this one right here 1, 2, 3, 4, 5, 6, 7, 8. and it's still 8 by 5, which makes it 40 square units. So they're the same size. They're the same size here, and they're the same size here. That's what we mean by maintain size. That's considered rigid motion. In order to take this one right here and change it to this, a couple of things have got to happen. We've got to move it down a little bit because, as you can see, one of the endpoints right here started off being at the point 110. It started off being at the point 110, and this one right here is now at the point 18. So we know we moved it down some, but look how big it is now. Now it goes from +8 to -8. That means it's 16 units tall now, and it's still 5 units wide. So this one's much bigger. It's actually twice as big. So this one, I believe, is 80 square units. This one is what we call non-rigid. And actually, in another section, we'll learn another name for this. It's called, since it's changed its size. Why is it non-rigid? Because it has a changed size. It changed size, and because it changed size, anytime it changes size, we call it a dilation. And you'll notice that dilation is not even mentioned up here. That's because it's in the next section. I think it's maybe, oh, I don't know where it is. This one's going to be translations, I think 930. It must be in lesson 10. But anyway, you will do dilations somewhere in the near future. I also want to mention, of all of the lessons that you are going through this semester, in my opinion, and I haven't yet, but I should go through the final, and it is probably the most heavily weighted section on the final transformations. You see, and I think this because there's so many, we have 4. There's translations, reflections, rotations, and dilations, and then you can do a combination of all of those. So since there's so many of them, they appear, I mean, it's a large proportion of your test that is over transformations. So some of you are like, oh, good, that's because these are easy. I get it. If that's who you are, then you're right. You're in luck because transformations are on the test quite a bit. Otherwise, you need to really study and pay attention to these because they are heavily weighted on the final. Okay, I'm going to stop the video right now so it doesn't get too long. You might need a break. But when we come back, we're going to look at some notation about moving these ordered pairs. Okay, so far I've just given you some vocabulary.